Okay, let's start. So, I thought of preparing some slides, but I don't like slides. So, I prepared a book, and I want to kind of test it out with you, like the content, and I think it will be fun. So, what I did is, instead of doing slides, I started this book as a Git book, so it's on its own repo. You can even follow now because it's like this exact version is online. Like it's really just a draft. It's really just kind of a dump of like some bullet points, but you can get it from here if you want. So it will be on Gitbooks, it will be on GitHub, so you can also participate. I have a couple of workshops to give when I come back to Montreal too, so the content will always expand. So I'm glad to start it all with you all here. Okay, what will it be all about? So it's really about Datavis. I mean, what I want to try to show is what is an insider view of Datavis. Like when I started Datavis, I had no clue what would be the day-to-day job. And now that it's been a while that I'm doing this, I think I can have like a couple of tips to give you. So my name is Christophe Viau, and here you have like my portfolio and Twitter account, but we don't care. I have something to say too. So maybe the first tip would be to learn Datavis before learning the tools. Like I see so many people that, for example, start with D3, and then we receive tons of questions, but these questions are really Datavis questions. And I think D3 is and I will speak a lot about D3 just because I'm really involved in this community. And I think it's a library that kind of illustrates what Datavis is. So that's what we will see. So yeah, learning Datavis, like the conceptual framework before learning the tool. So what is Datavis? Like, my own definition would be it's the art of science of turning data into graphics. So basically you have data, you want graphics. So that's easy to say, but you need some ways and some like conceptual framework to be able to do this. That's what we will try to see. Something that I call the Datavis pipeline. And I think it's very fundamental when you learn it, but also when you code it, when you design it. So basically we are using kind of a visual language, and I think, but what I want to show is that Datavis is what a Datavis designer does. So, and that's maybe harder to see. And now that I saw like many different type of Datavis guys, people, maybe I have like some experience to share, like what type of Datavis you are. So, like, I think the most important tip is like this community is huge. When I started, I didn't even know there was a community. Like in Montreal, it's not a well-known field. But then after my PhD, I moved to the Silicon Valley, and it's huge over there. So I started a meetup, and I think we are already like 7,000 members. So this community is huge, but you just have to find it. You can learn like with these like massive online open source classes. There are a couple of them, but you can find thousands of books, not just about D3, but about Datavis. I think the problem with the book ecosystem to learn Datavis is that it's really about design. And it makes sense because Datavis is about design. Like so, in this book, I'm talking like when I mention Datavis as a practice, it's kind of the Datavis design. But all these books are about design. So there's nothing about like this conceptual framework or what is like the actual task. How do you integrate as a Datavis designer inside a product development workflow? So that's the kind of thing they don't teach you at school, and you just learn the hard way. You can find tons of blogs, and I just like many people just list them. So and the conferences, there are so many nice conferences that just popped out like in the last like 5 years maybe. One of the most important is OpenVis, and it's in Boston. But there are like the more academic type, like InfoVis and all. So that's a nice way not just to learn about practices, because you have a lot of like Datavis people that just share their experience. Let's zoom this. Is it enough? Yeah. So that's also a nice way to meet with people, because like all these OpenVis conferences, they are on YouTube. Like you can watch them from home. But the nice thing about like paying lots of money just to go to these conferences, it's to meet with these people. Like the community is really smart, and if you want to get far in this, like you need to meet with them. This conferences is more kind of a data journalism one. Eurovis and InfoVis is more academic. IO is kind of between Datavis and maybe data art. Kai is an academic one, and VDA too. So you can also choose like the type of conference and the type of people you want to meet. So there are plenty of books in Datavis, but they are usually about design, which is good. But when I prepared this meetup, I was trying to see like what is not in this book. And in the community, I try to be like kind of a hub. I mean, like I'm kind of obsessed to find everything that the D3 community is doing and to like retweet it and try to package some galleries, ways that people can just find this community. So I'm trying now to fill the gap and what is not right now in all these books. For example, how do you integrate with a workflow? Because you can be the best Datavis designer, but then you start like in a product company, and like nobody understands what you are doing. It's a bit the same thing when you're a designer. Like, who's a designer here? It would help me to know. Nobody's a designer. Oh, this is a designer. Okay, a couple of designers. So I will not ask who's a Datavis designer or Datavis engineer. Okay, nobody. Cool. Because that's exactly what I thought. So I think I prepared the right stuff. Who's a software engineer? And that's my last question, I promise. Okay, so okay, that's nice. So what I will try to show is like what is a typical workflow, like a product workflow, because that's my specialty. I'm just trying to share my own experience. And where I think a designer can go, and a Datavis designer, how we can help at each stage of this workflow. So maybe like I could see multiple type of designers, like the graphic design, the guy that will draw the logos, and sometimes it's closer to marketing, and there are like the user experience crowd also. Those people are closer to the human factor, like how we interact with tools. Sometimes also closer to the information architecture. I feel that's one of the most important places to be as a designer, especially in a product. You can be a software engineer, so that's my case. I'm not especially a designer. I studied arts. But I never studied design, and I'm not especially good at it. So I usually work with a designer like Christian. So this type of designer is not just like I do something and then a designer make it look good. It's really an interaction between user experience, design, and Datavis. So that's, you can also be a Datavis because you come from the data. And I think that's a nice way to do, because Datavis, without understanding like really deeply what the data means and what a user means by data, it's just totally worthless. So I'm not a data science guy, but I have to kind of migrate to this path, because that's one of the most important things to learn when you're a software engineer interested in Datavis. Or the last thing, you can be a domain-specific expert. So you're not a data scientist because you're not like into stats and the computer engineering, but you know your stuff. like bioinformatics or maps. So when you are domain specific and you get some Datavis, that's where I think like there's some magic that can happen. So basically, what I really think, and that's one of the hints, is that Datavis is nothing when you are not something else. And that's always what I thought also when I was more into the contemporary arts. I was doing some electronics and programming. So I was a very good electronician for an artist. And I was a really good artist for like these electronic guys, but I'm not especially like a good programmer or a good... so what I think is it's the combination of all these strengths that makes a good Datavis engineer and a good person, I think. So that's kind of mixing stuff. Okay, so now when you know, like, if you are more like a tendency to be close to the graphic design, the UX, the software engineering, data science, or if you're a domain-specific expert, it's easier to see where you will fit in a product pipeline. So the workflow will be, of course, different if it's a product design pipeline, or if you are doing like one-off infographics, which is closer to communication, for example. You can build products that are more for discovery, or more for supporting the decision making, like we are doing in business intelligence. All these will be different workflows, and it's a different way for a designer to find his place. But I feel like I tried multiple startups, and some were in business intelligence, some were in network monitoring, and now Planet OS is in kind of saving the world, I think. Is that something like this? So very different companies, but it's always kind of the same structure. So let's try to see what could be a typical workflow. And I think nobody will be really surprised about this if you work in startups. So first you have this product owner, or like someone that is able to get you the user stories. Like, what do I need? But just in very simple sentences, like, for example, my user really needs to see the trend of my like stocks for exactly a month. So that's a very high-level story. And then there's a product manager that will try to convert this to, okay, but how will it look like, and how will I like break this down into requirements and then into tasks? And it's always a team effort, but it's usually led by the product manager. Then, typically, you have a designer. Okay, here are what we have to do. Let's just make it pretty or something. And then the developers will grab these assets and will just build it, and then you will have a QA session that will try to see if it works, and then, yeah. But what I think is the designer is not stuck here. Like, he's not stuck just trying to put like a face on top of your requirements for the rest of the pipeline to work. When I see startups just working like this, I call this a waterfall. I mean, like, decisions are made somewhere, and then it kind of like propagates down, and there's no retro feedback loops. That's kind of a sign that the structure, there's something missing. And I think that's the role of a designer, to try to make people understand that you need more loops. And the designer is usually good at doing this because he can put a face on stuff. And so that's what we will try to see. Where does a Datavis designer can fit in this product workflow? For example, first on the user stories, they can draw some wireframes. Especially the user experience designer can build some kind of storyboarding. And it doesn't have to wait for the user stories. Like, it can be very interesting to have this guy with the product owner to try to figure out like what are exactly their need. Sometimes the client thinks they need something, but then you have a UX expert that can tell them that that's just not what they need. They are just stuck in a mindset. They saw a product, and I think that's the role of a Datavis designer, and to show them like that there are some alternatives. this stage has to work with wireframes. Like it doesn't. You need to show that it's just a sketch. If you show some colors and stuff, like it will all distract, and people will think that you are already kind of showing them the actual product. So it has to be very sketchy. And database designers are usually pretty good at sketching weird things. So I think that can be a skill. User experience can be involved in the information architecture too. I think that's very important. You can have bad design, like graphical design, like all the colors and the font can be ugly, but at least if you have the right information architecture, the product can work. For the requirements and the tasks, a database designer has to know about the backend, like the data. It's even better if he knows like how the data was collected, how it is stored, how you can get it out of the database, how it's piped to the client, and then how you do your real database job, transforming from data to pixel space to the user space. So database design is typically kind of a full stack job. Personally, I'm more specialized on the client side, but I really need to migrate, and I'm pushing hard to try to understand more of this backend technology, which can be very complex. So, for example, at PlanetOS, we have these backend guys. Like, we have good mathematicians, we have our database guys, and all. So, but I need to learn that. So, the database designer can help to like bind all these peoples, because they usually work kind of in silos, because they are very specialized people. So I think it's the role of a database designer to make like this whole technology stack consistent. Database design often starts with design. The only formation like classes I know are in graphical school. It's kind of a specialty. Like you have your graphical design, and then you just add the human factor, and boom, you are a database designer. I don't think it can work that way, but it can work if the classes are good enough that you understand like who else do you need to work with to do your database job. If you don't know about the data, you need someone that knows about the data, for example. But I think it's a core skill to be able to design the UI, so really the graphical design, the layout, the colors. Okay, the tasks and the requirements, like, so the database designer is kind of a full stack, so he can help to sync everybody. And what helps the most is when you can put a face on stuff. Like, here is the product we are trying to design. That helps like the whole company to focus on a single thing, single project. Last stage, QA. It's not too obvious how a database designer can participate in QA. Like, they don't talk about it in schools and in books. But my own experience is when something breaks, and it can be like anywhere in the technology stack, what will break? It's your design. Like, so you can receive a phone call like at 2 in the morning, hey, your pie chart is exploding. And basically, yes, like that's always your stuff that will break, because it exposes the work of the whole technology stack. That's a nice thing, because I feel that my job is just to show what is like the good things that my whole team is doing. Like, I'm just doing nothing, I'm just exposing stuff. That's what I feel I'm doing, but I'm also exposing the bugs. So I'm glad I have a team that understands that's also my role, and is not like pointing fingers. But so you need to know that you need to react quickly and be able to get like to track back in the stack and see where it breaks. Sometimes you will also work more on Datavis to see where it breaks than on Datavis that could actually breaks in production. So I think a good job in Datavis is not even client-facing. It's the job to internally see if things are going well. That's the kind of thing I personally like to develop, like make people see what they are doing. That's it. Is it okay for like the pace or yep? So that's a bit like where I think a database designer can fit in a product development workflow, and it can be the same thing in newsrooms and as far as I know. So, but it's very important to be able to expose it, because if you don't want to get stuck as a graphical designer, if you are a UX person, and I saw a lot of problems like this, like not be able to expose what you are as a database designer. Hey, let's talk about this pipeline. I think that's the most important thing to know in Datavis. That's important not just for design, that's important to understand what is your job and also to implement it. Since I'm more a programmer than a designer, I like to bake this pipeline into my libraries and my code. D3 is very successful because it has something like this also. Like it only helps you to put a pipeline, a database pipeline, on top of web technologies. So what is this pipeline? There are a couple of like fundamental books, like an operator interaction frameworks for visualization systems. It's a bit complicated book, but when you look at this schema, it's not too bad. Basically, you want to go from data to graphics, but what does it mean? When you program charts libraries, like I do, you see that it's not just like mapping data to graphics. There's a whole data processing pipeline. It's not just to acquire the data and to process it. You have to do a lot of things that here is called analytical abstraction. You have to compute derived data, you have to convert the data, you have to transform it, and nobody will do it for you. Like, if you have some data guys, they can do their part, but nobody will do the part where the data is cleaned, and you need to just like transform it for your visualization, because you need a specific format for your stuff. So at least you need to master this data part, which is called kind of the data abstraction. And the visualization abstraction is the same kind of thing. Like, you need to think about, you don't map it to visual elements. You also need to map that to kind of a layout that will give you a chart, that will give you a dashboard with multiple dashboards. So that's an abstraction. And then you will render this to the view. So between the data and the view, there's kind of a whole pipeline there that you need to know when you start. This academic paper is maybe a bit more specific about the pipeline, like how you go from data to the visualization and to, so it talks more about like the operation to go to each stages. So that's the kind of paper you can read if you're interested. But what I'm trying is to simplify the pipeline, not to dumb it down. I know like that everything, like everybody here is brilliant, but it's because I think it's as simple. You have the data space, you have the pixel space, and you have the interaction space. You can see that the interaction space is not even in these papers. They are pretty old papers, so maybe like the focus was not too much on the interaction part, but I think it's one of the most important piece. So basically, data, pixel, interaction, for me, is a better pipeline to understand your job and like how you will break down the code, how you will break down the work between multiple teammates. For example, the data space, you can collect the data yourself. Like if you are a sensor guy, you know where the data comes from. Then you have to store it somewhere. Like you need the raw data somewhere. You can acquire it, you can collect it, but it needs to live somewhere. Then you need to format it in a way that you can at least use it. But then, like, you need to clean it a lot. And cleaning is maybe the worst part. Like, if someone here works in data, I'm pretty sure like 90% of your job is cleaning the data. And at Planet OS, that's a lot of the work too. So cleaning the data is not just because there are some missing values, it's sometimes like some inconsistencies, and that's a full-time job, just cleaning the data. But transforming the data is also something else. Like sometimes you just want a slice of the data, like a time slice, or you want to group it, you want to derive some data. Then you can go to what I call the abstract data space. This data lives also in kind of an abstract form, like it's not close to the raw data, but it's kind of an intermediary data that is useful for you to then map to graphics. An example of this is that you need to scale your data. Like if you want like to present some stuff in a logarithmic scale, that's what I call like the abstract data. If you need to compute some statistics and some metadata from the data, derive some data sets, merge some data together. So you will spend a lot of time in this space. Before going into the pixel space. So I think that's where the most fun is. Like personally, I don't have much fun in the data piping. I have a lot of it to do. That's probably like 75% of my job. But what I like is the pixel space. Like, give me the clean data, and then I can have real fun. Basically, you take your values and you try to map them to something. What is this something? Like, it can be the position, the size, the angle, the colors, the difference between multiple positions. It can be like a calculated value, like the total, like or the height of the stack of a stack bar chart. But so you just have a certain set of graphical component that you can map to. That's what we will see in the next slide or section. And then there's only so much like ways to use these graphical components, like the position and all. Like you can like put them side by side. You can nest them. You can link them. So that's interesting to see that there's only like one set, like a finite set of possibilities in Datavis. And your role is to find the one that fits the most with the project. So the pixel space is about mapping to graphics. It's about the layout, like the internal layout of the chart and the layout of these charts together in a view. Then the interaction space, I think, is really interesting. Like, do you need an animation? Sometimes you need animations because you need transitions between different states to keep the mental map between different states. Sometimes you just put animation because it's easy to do in D3, but it's totally worthless. So I think now like the community is mature enough that you have some conceptual framework around if we should animate stuff or not, if it should be interactive, like dynamic storytelling and what I call scrollytelling, like you just scroll some news and like things just appear. That's kind of a new form of a narrative that was kind of driven by the Datavis community in the newsroom. Then you have like all these widgets. Like a Datavis rarely lives by itself. Usually, at least in a product, you have kind of an ecosystem of manipulators. For example, like we often forget that Datavis is not just, for example, bar charts and colors, and you also have like tiny details like the tooltips that can make a very big difference. So a tooltip is kind of an interaction. So do you need it or not? If you have a tooltip, it means that you have some values that are not shown and that you need to go and find it. Maybe it's not the right way to do it. So there are a lot of questions that are not just mapping data to graphics, but that are like about how relevant are all the interaction you can get with this mapping and all the feedback between the user and your graphics, because the graphics is kind of a proxy for your data. So, good example of conceptual frameworks, like the Bible in this domain is the grammar of graphics. probably if you have like one book to read to understand what the pipeline means, it's this one. It's not, I would not say it's an interesting book because it's very technical, but it's very thorough. So that's by Leland Wilkinson. By the way, what I like about this community is also that you can work with these guys. Like if you want to work with Leland, just move to the Silicon Valley. He works at a company called H2O, and they are recruiting, like at PlanetOS 2, and like a bunch of guys are. So when you see like a great master of Datavis, you can ask the question, is he dead, or can I still work with them? Can I still see a conference with them? Like one of my favorite Datavis design book is by Tamara Motzner, but she's a teacher in Vancouver. So you can just go there. ggplot2 is a graphic library that is built for R. And in my opinion, that's probably the best one, because that's the one that is really closely following the grammar of graphics. That's kind of an implementation of the grammar of graphics, which is more a conceptual framework. So yeah, so that's a pretty good one. I will get you later like a list of implementation in JavaScript, because everybody is trying to make one, but there's none like that just stick, like they just all die. I don't know why. I think there's a serial killer for like ggplot on JS. So, and D3.js takes also is inspiration from this Datavis pipeline. Like, so the summary of this chapter is really, you need to know this pipeline and how it applies to the code and to your workflow and to your mindset and to the way you design stuff. All good? Anyway, we'll have a period of questions after. So keep some notes, and I will be glad to answer everything I can. And we can also continue discussing after. So, okay. So now that you know the pipeline, or you have a lot of reference in this book to continue the exploration of this pipeline. But basically, it's like how you bind from data to graphics. But what you're doing is you are mapping data to graphics, but to some visual variables. And there are a lot of books about this too. So, for example, this one, The Structure of Information Visualization Design Space. This one is trying to characterize each chart by what is the data type and how each data type was mapped to which retinal properties that they call it. So, for example, if you have some nominal quantitative data, some geographic data, how like each of these data types were mapped to, for example, XYZ position, the time, or the color, the size, this kind of stuff. So for this academic paper, you can use this matrix, and if you fill it, you have kind of a characterization of each type of graphics. What I like to do is the opposite. You just randomly fill these things, and you try to draw a graphic that match with it. Like you find some data, and you... what I did once is just like a huge matrix of every possibilities, and just try to put one type of chart into each of them. So that's always nice to have kind of a conceptual framework to explore your design space. And most often it's just to see that what you need is a bar chart. But at least then you know. So you need some kind of a grammar. I mean, like, what is a point, a line? There's, of course, when you work in Datavis, that's a geometry job. Like, you need to like this kind of stuff. Like, what are the thing you can map to? There's only kind of a finite set. So here, it's one of the paper I wrote a couple of years ago. I was trying to see that, like, when you have like the data type, every combination of data types on axis can give something different. Like if you say you have some constants, so for example, this one is what is map on x, on y, on the width, and on the position. So, and with a very simple conceptual framework like this, you can try all the combination and you will always find something. Like what is a bar chart where you also encode something on the width of the bar chart. What is a bar chart if you also use the position of the bar chart and not like the y at the bottom. So, and each time you can discover new things. Most of them will be totally useless, but it's a fun exercise to do, at least to really understand like why some of the graphic types are always coming back. Maybe that's also because they are the best fit. So a simplified grammar for you. I think if you at least really well understand these different data types, like what is a categorical, quantitative, and also a constant. Like sometimes you just map a constant on a visual element. Like on a bar chart, the position is just a constant. Like it's not mapped to some data. And if you have only these graphical variables, like x, y, size, angle, color, you can do pretty much everything. Like a lot of the charts library that I design, it's just I'm trying to describe how I map to x, y, size, angle, color, and that's it. And then you have what I call assembly strategies. Like it's not enough to just map to something. You also need to know like if you place them like side by side, if it's one inside another. I will give you some examples here. For example, like you can have multiple charts on the same plane, but you can also just join them together, and it can mean something else. You can superimpose them. You can nest them. An example of chart where it's the same kind of information that you just like change the assembly type, and it kind of means something else. Like this is just a binary tree. So like the assembly type is the connection. So you just have your boxes and then you connect them. In this tree, you also have kind of a hierarchy. Like you can think that the one on top is like the best or the first, or so it means something. But with the same meaning, if you just like put things kind of in a stack instead of with connections, this one is called an icicle. If you take an icicle and you just like put it in polar coordinates, you get a sunburst like this. So this visualization is typical, for example, in the apps that shows you the content of your directories on your computer, because you see the hierarchy and how they are nested, you know. So this thing, you just put it in a circular space and you have a sunburst. When you use kind of a nesting pattern, this one is called a tree map. So that's the same information as this. Like this node is this big box, and then you have boxes inside boxes. So this one is maybe, it can be a bit hard to understand, but the client gets it when they know that their data is kind of a nested thing, especially when you can click on them and then you can like you can kind of drill down and you can you see that this structure, like this visualization, is a bit complicated, but it's because the data is a bit complicated. It has some hierarchy in it, like it's already full of meaning. And this one is just kind of an experiment I found in an academic paper to have a graph that will use superposition. I think it's just not good, but it's just an example that you can also use superimposition like this. If we look at chart types, you can see that like there's not a big difference between a bar chart and a stacked bar chart. But one big difference is here you can have an axis, because like the main value of the data is mapped to the height of the bar. So like that's like the classical example in a Datavis. They are all aligned on the bottom, so you can compare these height. Because the visual system is pretty good at comparing this kind of stuff, way more than to compare, for example, in a pie chart, the angle, or worse, like the area of a slice of a circle. That's kind of a thing we have difficulty comparing. So, but in the stacked bar chart, you cannot put an axis here because you have multiple bars that are stacked. So this axis will not be meaningful. So that's the kind of thing you can just understand, like when you use it and you just try to map some data, and the same thing here. Like this is the same as this one, but everything is scaled to be 100%. That's why I call it like a percent stacked bar chart. I don't know if there's a better name. But if you take like just one of these bars, it's in fact a pie chart, because what you want to see is you want to compare like multiple stacks together and how they are divided. So here the top of the stack is meaningful, and here it's not, because what is meaningful is just like what is like the distribution of your data inside the same stack. So it's just an example to show that like these three looks the same, but when you look at them, they mean something different, and it's a very different mapping. And then you have this bullet graph. Bullet graph is a bit weird, and it's used in like business dashboard. And basically, it's kind of a stack bar chart when you look at it closely. Let's look at it closely. Is it close enough? Oh, that's big. So basically, like I don't want to explain it too much, but it's just to show that you can get some weird charts, but when you explain it just a bit, and you just you can get more value out of this because it maps more things. Okay, first, here is kind of like, okay, that's my revenue, and that's a target. Like, if I go there, I'm just broke, and if I succeed a bit, I will be here. But if I go here, like I'm rich, I can just stop working. So that's kind of like your. In fact, this one is a gauge, like in a car. Like if I go too, like if my engine turn too fast, like it will just explode. So, and this line is where I am. So as you know, as you see here, Stephen Viau, the guy that invented it, is probably rich because he attained like all his goals. So that's very typical on KPIs dashboards, where you have like goals and you have kind of things that you are trying to reach. So that's already meaningful to know like what are like the span of things where you consider to be like bad, good, and very good. And it's good to see where you are in this range. And then you have this line. This line is a bit like in a view meter, like on sound systems. It shows you like the previous performance. We call this a swim lane, like in like a swim races, competitions, where you can see like where the guy was like on the previous run. So that's the swim lane. So in this one, like the revenue is bigger than, for example, the revenue last year. So this one too is just a matter of trying to find the right mapping, and sometimes you have to just like understand it, and it brings instant value once you get it. And Stephen Viau mentioned this one and designed this one to replace the gauges. This is very typical of business dashboards, because usually business people are not designers, like they just want to see things. So a gauge, like it tells kind of a story, like hey, it's like in my car, I go fast, I go slow. So that's very easy to map this metaphor to my business. And here, like I can say, I go too fast. But the problem Stephen Few has with this one is that since it's a circular, you need to see the angle of things. So that's a bit hard to say, like, okay, I'm almost there. I think I'm at like 30 degrees there. So for the visual system, it's way better to always like if you want to compare multiple gauges, it's easier to do it if they are all if they all encode like the same way, and you can really compare them like here. Like it's easy to see that this one is performing better than this one, for example. So some visual variables are easier to understand, but sometimes you need to sacrifice this kind of visual performance for the metaphor. Like if the business decider, like he looks at this and he doesn't understand a thing, you just go back to a gauge. And like everybody in the Datavis community will just say, hey, gauge are so bad. But like what counts is Datavis is just for a user to be able to take some decisions, some action. So that's the only thing that counts. Sometimes in Datavis design, we are kind of stuck in our mindset, like stuff are better than others, but I would say like if the client wants it that way and you are not able to convince him, it's just better that way. Okay, so here you have tons of them, and I will not explain them all because we can go forever. Let's move on. You have, anyway, 2,050 and 500 examples here that I'm collecting like since like 2012. I'm just collecting everything I can, and I just dump it here. And if 2,500 seems to be a lot, I thought too, but then we developed this one, and now we have 13,000 examples. So this one just got out a few months ago, and so we worked on it with the community, and like everybody is participating. So what is important to understand there is the D3 community is especially good at sharing stuff. Like we have a way to share, and it's easy. You just use a gist, and gist is a Git repo. So that's all explained in the book. But so and we have blocks. Blocks is just a gist viewer. So basically, we have a way to put our stuff on the web. And so like everybody can just clone it and modify it and then share it back. That's why we have like 13,000. Yeah, so what it means also is if you have a product, if you have something to sell, if you have something to share, you need to find a way where people can share back. So I think that's one of the big success of D3 is it's fundamentally a thing to be shared. So like there you can search for tree maps. Then you will find plenty of them. Like radial tree map, if it even makes sense. And in the community we tend to say that everything is a fork of one of the My Bostock example, which is the creator of D3. So you will find a lot of variant of the same thing. So that's what is nice with this community. You can get some inspiration, and when something you think is cool, you just use it and you modify it, and then you share it back. Yeah.
There is no sort of creation because you say, well, I think it's cool, but that doesn't mean it's good design.
Yeah.
So there should be clear formats of what is good design beyond
Yeah.
the client wants.
Yeah.
Is there a sort of curation inside this?
At all. So this one is just a huge dump. Yeah. So the curation, you can find it more in blog posts and in books, and also in the D3 community we have some examples that we know that comes from the master, and like everybody is following the same. So yeah, like a curation is a big thing, and that's what I'm trying to do with my gallery, and that's why it's not dead, because this thing is just what is shared as GIST. That's it. Like, if you have some nice D3 examples in a blog post or in a product, like, it will not be there, it will be in mine. So every day I find stuff, so I tweet them, and then I put them into the gallery, and I try to tag them, and that's my way of curating stuff. But yeah, like, that's a huge undertaking. Okay, so yeah, you can find tons of examples. They will not all be good, but they will always have something to tell. So, and here I link to some of the weirdest that you can find here. I will go quickly into this. When someone wants to start D3 or even Datavis, they always think, hey, I want to play with D3, and that's it. So the community is fun, and like there's a lot of trend, but maybe you just don't need it. Like, if you don't have to code, just don't code. Like, we use D3 because we have some custom charts to do, or we have some charts that are so specific, like even if it's a bar chart. An example is I worked for Boundary, and they are into the streaming analytics. So like, every charts library will kind of break if we just try like to stream some data like as fast as you can in it. So I always end up building my own stuff. But if you can afford to not code, that's the best thing. You can use Tableau. Tableau is one of the standard, but even bigger standard is Excel. It's a bit weird because Excel is kind of seen as like the worst tool possible, but that's the tool that is out there, and the Datavis capability is pretty good too. You even have a binding between D3 and the Excel online stuff. So sometimes that's just what you need. Like, it depends on what you need to do. Sometimes it's even like a tool that I found really bad, but business objects, they are doing good tool, but if you look at like the standards for the chart, like it's not the best, but it's really targeted for the business intelligence community, and then it fits with your database and with your mindset. So just use it. Then you have like all these tools are charts generators, so they will build charts for you. I worked at Plotly to kind of develop a set of tools for them also. So you just go there, you upload your data, you choose a bit of the styling, and then you share. That's it. Recently, Access was open sourced. Same with Data Wrapper is kind of an old one, but now it's kind of replaced by ChartMaker. It's not replaced. It's the guy that worked on Data Wrapper came to work for the New York Times, and then he developed kind of the next version of it. It's called ChartMaker. So a lot of those comes from needs in the newsrooms, where you don't want like all your journalists to be able to code their own database, but you want a simple way to just say, okay, just upload your data, and we give you the best default possible. So use that. And then when you want to go a bit deeper, you can use just a charts library. I don't especially like high charts, but it's one of the biggest there. It's probably too big, but anyway, like it makes sense to mention it because you will see it out there. I met with the Zoom Charts guy, like they had a booth at Latitude 59 conference, which is a very nice conference. Yeah, I think Annika will agree. And this chart is one of the only that I know that is not made with D3 and works very well, especially for mobile, like for interactivity. Plotly.js, like Plotly is an online tool to build charts. It's kind of more for the scientific community, but they also open source their charts library, and it's huge. Like it's probably the one with the most diversity of charts type. And it's all free. Like, these guys are really awesome. Then you have a lot of D3 charts library. They are not all good. Some of them are just dead, but I still list them there because you can get some things from each of them. But there are tons of them because everybody has the same need. Like when you have an example and it works well, then you need to package it. And you need to integrate this into your tool. So that's the job of a Datavis designer too. Like when you just clone something and it works, like it's just the first step. So then you have plugins. Like if you want to dive a bit deeper, you can just assemble some plugins. Like instead of diving directly into the core D3, you just assemble some more high-level things. And then if you have really no choice, and that's my case, you have to program. When you program, I think the most important, and I'm glad that's what I studied. Before programming, I was reading books about programming because I liked the way that you can have a conceptual framework. Like an object-oriented approach is very different than a functional composition approach. So that's one part that I like. And that's the same as like taking the Datavis pipeline and try to see like what is the kind of code that fits with this pipeline. An example of code that fits like this. The latest charts library I'm working with is not even a charts library. Like it's just some code to build your own pipeline, and that's it. So basically, the real like core functions are just a few lines of code. So, and it's a pipeline. So then I just have to know, okay, what is my data module? And the data module is just encapsulating all, like the data format that comes in and how it's transformed to be passed down to the scales. The scales will try to map from data space to a pixel space. And then same for the X and Y. And then there's kind of an abstract space to prepare the scale for an axis, because an axis is a component. But it's just an abstract component when it's not rendered on your view. Like you just compute some positioning from your data. Then you have the components. When I have something that I call a component, it means that it goes into the view. Like that's a rendering module. The panel is just like the thing that is around your chart, and it can like contain some line shapes and some shapes, some axes, titles, and tooltips. In Datavis design, like there's a lot more than just boxes inside the box. The axis is a very tricky thing to get right. The color scales, especially like in geographic mapping, it's an art by itself. And then like positioning the titles and all, so that's a lot of work. But at least like when you have a pipeline, you know exactly like where it can break. You know what you can just swap. Like if I want to use the same line chart here, but I want like another data format to go in, I just change this. So what I'm trying to say is just that like when you really have like a strong opinion and like knowledge of your domain, like the Datavis pipeline, you can really use it as your programming pattern. I'm almost done. So if your brain hurts or if it's boring, it's almost done. Okay, maybe one of my last tip is when you learn like the conceptual framework, you need to learn the technologies. D3 is really just like a thin layer on top of your web technologies. A lot of the question we receive in the community is really like, for example, can we do this with D3? And the answer is always, of course, if you can do this with your web technologies, D3 will just give you tools to do it more easily. So the real thing is to learn this. HTML5 and all his its components. Maybe the most important is the DOM. So the DOM is really like the rendering tree of your browser. And it's an ugly thing. Like it's messy. There's a good book on it. It's called Dumb Enlightenment. Like you can like attain, I think, nirvana by studying the dumb. But so the dumb is a pretty bad thing. So that's why but D3 works with the DOM, like it's binding things directly to the DOM. So that's probably the first thing to learn. And when you learn the DOM, you have to learn JavaScript because you have to learn how to manipulate the DOM. So that's one thing that they don't teach you at school. Like that's the web technologies are bad. Like JavaScript is not a good language neither. Like you have to find the way that it can behave properly. And I think D3 shows the way because the design pattern, like the coding style in D3 is pretty good. So you have a lot to learn from that. CSS, Canvas, etc. So really, you can do a lot of stuff without using D3. Like using plain JavaScript with plain SVG will work very well too. You have more libraries that will help you like hide the ugly side of all of this. Like if you use P5.js, which is like the next version of processing.js, which is a JavaScript version of the Java version. So that's a very old tool that was built for people with no knowledge of programming. Like when I teach programming to art students, they usually don't have like the kind of mindset to program, but I use processing because the syntax is clean and you get instant gratification because you kind of get instantly to your graphics. So use a library that will kind of abstract out the bad stuff. Snap SVG is the same for SVG. It's from the guy that developed Raphael.js at the time where you had like to shim between Internet Explorer and all the others. So that's a pretty good one. But then sometimes the answer is only is to use D3. So that can be, but I like that you need to go like through all of this before knowing if you need D3. So just to get quickly there, D3 has a reputation to be hard to learn, and it's not because it's lacking some documentation and some examples and the community is there, but like with the community we are always trying to see why is it hard to learn. Because it's been a while that we learned it, and now we kind of master like the basics, and we have to remember like what it was to start with it. Personally, I think it's hard to get because it uses a very functional style of JavaScript programming. But that's not a bad thing because if you program in JavaScript, you need to learn the functional style. So yes, that's a real thing that is hard to get. But what is not totally true is that sometimes you just start with D3 without learning the basics. So that will be hard because you are trying to learn a tool, but the tool just exposes you some stuff that you don't know about, and then it will not help you understand it because it's the like low-level technology. Also, sometimes D3 is confused with an abstraction library like jQuery and all, but it's not an abstraction. It's really just a set of tools to help you work better with web technologies. So, and the last thing is, and that's partly why I wanted to write all these slides as a book too. All the books I know, and I know probably most of them, and I wrote some too, and they are all the same in that they start with the enter, update, exit pattern. So when you start learning D3, you say, okay, that's where I should start. It's kind of a way for D3 to say, okay, you have like as many data points, so I will give you like as many DOM elements that will like represent like squares, okay? And then you bind your data to this. You just describe how you want to map your data to your DOM. And then you just pass some data, and then it will know how to do it. But yeah, so that's kind of magic. So you try to understand how it works, but it works in a very weird way. And it takes some time to to understand this. And although it's very fundamental to D3, I think it's not the way to start. And like I still think like you should forget about this and let's find like an alternative learning path. And that's my second to last slide. And that's it. Like the next version of D3 will go out like in a couple of weeks maybe. Mike Bostock is working very hard on the next version. The big difference with D3 version 3 is it's all on modules. So you can pick just what you want. So then it's easier to see that D3 is not a framework, like it's not a big tool, like it's just a set of tiny tools. If you take the Datavis pipeline and you try to map all of these tools to the Datavis pipeline, I think it makes it very much easier to understand what D3 is. Like you have some data space components, like to load the data, to generate some data, to parse it, to format it, to manipulate the data. Then you have the graphic space, which is not the render space, but just like the computation of these graphical variables. Then you have like this view space, now that you have all these geometries, you just need like to dump it into your screen, and then you need some users to interact with it. So I think the next version being modular, it will be easier to find the way you want to start with it. You just get a piece of it, and probably the D3 selection, which is the data binding thing, you can even forget about it and just go back when you see the need for it. Last slide. So, what does it mean? Now that we saw that a database designer is something maybe very, very specific, but it's hard to define exactly what you are as a database designer. But I think it's important because then you know how you can help the whole product pipeline. Then you need to learn the real stuff. The tools are always just tools. Like if you learn to use a hammer, like it doesn't mean you know how to build stuff. So the conceptual frameworks are very important. I think one of the success of D3 is that the conceptual framework is kind of baked in the tool. So, and it's kind of a tool just to apply this conceptual framework to web technologies. You can ask plenty of questions, like we are always on the Google Groups, Stack Overflow, on IRC, Gitter, and Slack. The Slack community is particularly interesting. So you go to the Google Groups, you find the Slack community post, and you just ask to join, and we'll be glad to help. To share code, there are a lot of places you can do it. So this gallery is not just a gallery. It's also a viewer that you can edit in real time, and then you can fork it, and you can see the result in real time. So learn how to integrate with this ecosystem of tools, and show your examples. Like it can be on my gallery, it would automatically go into the blog builder gallery. There's an official gallery also on the D3JS wiki, so just share. And you can share also if you're better at writing blog posts. I think blog posts are very important in this community because we see a lot of examples, but what is more important is to see what is the process. And it's very hard to get, and that's a bit what I tried to show today, is that like you can learn a lot from books, but you learn way more by just working on it. And I think it's all about the process, the workflow, and the pipeline. That's it.
Ooh, thank you.
Yeah, so questions, really, like the discussion part. Do you have anything to ask? We're gonna give you the mic. No? Okay, Christophe, okay.
Can you share the URL of your book?
Yes. So there are multiple, but let's get this one.
Hi, thanks for the talk. Can you show some examples that you built, for example, for Planet OS?
Yes, of course. We're building tons of things. So, what I like working at Planet OS, no, like it's not just a recruiting meetup, but since I'm here to share my experience, I was not especially good at maps when I started, and that's kind of a map company. And now that we are getting more into charts, I'm more comfortable, but I learned a lot. So that's the kind of thing we are trying to do, like have an API to access the most kind of data on and it's all about weather and oceans and so that's the kind of thing we do there. One thing that I can show is that since we have a blog, what I'm trying to do, because I'm trying to give like as much as I can to the community, is I'm writing some stuff. And so as I told, like I like to see processes, and I think a blog post is a nice format for this. For example, yeah, I think this one is a good example. When we deliver data sets and we try to deliver them like each week or every 2 weeks, we always try to have kind of a package to show how it can be used. For me, it's also just a way to get people to understand better what you can do with an API and with charts. Like an example is I had to build like some fancy colors to go on maps. So, and like every time I learn something, I try to write a blog post about it. So this one is just a way to like enhance the local contrast on a picture and on a map to choose kind of a better coloring that shows more the range of the values. So like every time I have something to share, I also try to bundle this as a plugin that I can also share with the open source community. So like in this blog, we have tons of these of things like this. So I don't know what to show more than to say just go see the stuff. And by the way, like the most important is that we need feedback. Like we need to see like what people want to do. We have some skills and like how to like deliver these data sets in a consistent way. But what we need the most is what will people build with this? What are the use cases and how we can help? Because the only goal of this company is to try to help people get to their data. Yeah, so that's a couple of examples I'm doing here. Just a small detail that on the book you have a link also to my kind of portfolio, and in this one you can see more. So stuff that are not even published, like some prototypes, and also stuff that I did in past companies, and stuff that we do that are kind of side projects for us, like posters for understanding like food security visualization. So that's also the role of the Datavis designer, is to find like opportunities to show stuff. Yeah.
So since you're dealing with live data and things is updated all the time, so and you're dealing with sensors, so how do you communicate on reliability of sensors? If there is a fail, or there is some sort of problem with the transmission, is there a data visualization language for that?
Yeah, that's a very good question, because that's also something that you don't learn in books, because that's a bit domain specific, but I think the community is there. Like that's the kind of question we are trying to answer. Like we have kind of a grammar of graphics, we have a practice, but then we also need a grammar of interaction. So some people are working on this, because that's
there in academia somewhere to look.
Yeah.
Yeah.
Yeah. And like an example is that one guy in the academia worked on the next version of Vega, because the challenge was how do you describe interactions? Like interaction is kind of an interaction thing. Like you need some feedback, but so that's the same kind of things we need also for uncertainty, because like the Datavis, it tries to show some numbers, and when it's not really a number, like it's a range, or it's a very specific numbers, but that means something that is fuzzy. We need to be able to show this. So one tip is you need to show the gaps, and your Datavis, it has to fail to show if the data failed. Like there are a lot of things like this. Like when something is fuzzy, you can have a fuzzy line, like a blur. So there's a whole grammar that we have to develop to really see some high-level components of the data that are not just values, but that are like messy data. There's a tool called Trifacta. They are very specialized in cleaning data.
Beyond the messy data, also like there are the physical component can fail, and you can discover that through your own data.
Yeah.
And there should be some sort of grammar just to know to differentiate between communication problems and physical problems.
Yeah, and like an example of this is like when, as a Datavis designer, I receive like null values. Is it because my sensor doesn't deliver things? Is it because there's nothing? Is it because the data transform like zeros to nulls or like nons? Or and that's a bit hard to know. But you need to be able to show this as a visualization. Like why is there a gap here? Yeah, so that's a good question, and I think there's no answer like that have a conceptual framework on it. And I would like to work on this.
Really, thank you all for coming. I'm very, very pleased so many of you came, and Christophe, you're truly smart, and that's really great. I think everybody agrees. Woo!